All right, good afternoon, everybody. Um, this is another question, and this question is on mathematical induction, and we are to prove by inductive hypothesis that the summation of k plus 1 is equals to n plus 1, n plus 2, all divided by 3. So this is our question. So we'll be checking out the following steps to prove this question. So we have step 1. So step 1 is the base case, and the base case implies that you are to check if the left hand side is equals to the right hand side. So we are checking for all value of n equals to 1. Now when n is equals to 1, we are to insert anywhere we see k as 1. So that will be 1 open bracket 1 plus 1, and that is equals to 2. So secondly, we are to check if for the right hand side. So for the right hand side, anywhere you see n, you are putting 1, and at the end of the day we have 2 as well. So you can see that the left hand side is equals to the right hand side. Now it is not necessarily that you check for when n is equals to 2, but in some cases it is expected of you to check for when n equals to 2, but it is not necessary that you check for when n equals to 2. So you can go directly to when n is equals to k, and thereafter you move down to when n is equals to k plus 1. Are you getting it? So that's step 1. So we are moving to step 2 now. So step 2 is called the inductive step, or it is also known as the inductive hypothesis. So this is why the topic is called mathematical induction, right? Because there is always an inductive step. You are inducing something, right? So the inductive step implies that n equals to 1 that you've inserted, does it simply means that for every value of n that you are going to put, will it still be that the left hand side will be the same thing as the right hand side? Are we saying that when n is equals to 2, when n equals to 3, when n equals to 4, when n equals to 5, will the left hand side still be the same thing as the right hand side? So that is why we have to use a general value, a general symbol to represent every other values. So we say that when n is equals to k. Are you getting me? So n equals to k is not just that we are putting n equals to k, it's simply representing other numbers. Are you getting it? Now assume the formula holds for n equals to k. This simply means that anywhere you see the value for n, now you are going to put what? K. So that's k plus 1, k plus 2 divided by 3. So similarly, we need to prove for when n is equals to k plus 1. When n equals to k plus 1 simply implies that you can have an odd value. If you put an odd value, even number, odd number, even number, it will still be that the left hand side is still the same thing as what? The right hand side. And you can see when we substituted when n equals to k plus 1, we have that expression. So we are moving to the next. You have to pay full attention to this part, because there is something that might seem very confusing here, but we have to refer back to step 2. Are you getting me? So using the definition of summation, now you have to know when to expand a summation symbol. Are you getting me? You have to know when to expand a summation symbol. Now the first value for the expansion, you can see the left hand side is summation of k equals to 1 to k plus 1 of k open bracket k plus 1. Now we want to expand that first term. So if you expand it, it simply means that you are going to put the value for k first, then you are now going to put the value for k plus 1. Are you getting me? We said from k equals to 1 to k plus 1. Now if you now put k, if you expand it now, summation symbol means you are expanding the first term. After expanding the first one, the next one is going to be plus. So you keep on that summation, that symbol means sum, right? The sum simply means plus. So if you have k open bracket k plus 1, if you want to expand it, the first term is going to be k open bracket k plus 1 plus the next term will be, anywhere you see k now, is going to be k plus 1. Are you getting me? So that's going to be k plus 1 open bracket k plus 1 plus 1. We substituted k plus 1 to all the places that we have k. So that is that for the first term. The other one is going to be k plus 2. The next one is going to be k plus 3, and so on. Now we are going to substitute the inductive hypothesis. If you remember from step 2 that we have the inductive hypothesis, we already have the inductive hypothesis from k equals to 1 to k open bracket k plus 1 as k plus 1 k plus 2 over 3. So we substituted the inductive hypothesis back into the step 3. So when we substituted, we have the last expression below. So we have the last expression below. Now where is k plus 2 coming from? K plus 2 is coming from this one. We have k plus 1 close bracket plus 1. So that 1 plus 1 there gave us 2. So the above the first term is still the same thing as the second term, provided that we've substituted. So when we substituted, that's the expression that we have. That's the expression that we have. So we are moving to step 4 now. So go back to step 2 and check the inductive hypothesis again, so you will see where we are coming from. So the next thing we have is the simplification. We need to simplify the expression that we've already written. So we factorize out k plus 1, k plus 2. There was k plus 1 and k plus 2 there. So when you are watching this video, I will advise that you write all of these things inside your note, so you can be able to lay references to the previous slide. Are you getting it? So we factor out k plus 1, k plus 2. When we factor that out, we have the expression below. So now we can go ahead and simplify k over 3 plus 1. K over 3 plus 1 is still k plus 3 all divided by 3. And don't forget that we already factor it out. So it's more like it is the one multiplying everything. So we have our expression below to be k equals to 1, k plus 1, 2 k plus 1 is equals to k plus 1, k plus 2, k plus 3 all divided by what? By 3. So we are done with the proving. So don't forget that we started with when n is equals to k plus 1. So when you substitute when n equals to k plus 1 now, you are going to go back to the question. You will see that is exactly the question that was given to us. So the last step now, you see what I mean. So as you can see clearly now, we have shown that summation of k equals to 1 to k plus 1 of k open bracket k plus 1 is equals to k plus 1, k plus 2, k plus 1, k plus 1 plus 1, k plus 1 plus 2 all divided by 3. So that's what we have successfully shown, right? So, and don't forget, by the principle of mathematical induction, we know that n is equals to k plus 1. Are you getting it? N is equals to k plus 1. So when you substitute the value for n to be k plus 1, you have your final answer. So we have successfully proven that the left hand side is equals to the right hand side. So for those of us that have not subscribed to this channel, please, I'm begging you, kindly click on the subscription button. Thank you.